We have two sessions this morning. First session is defining and understanding El Niño. And the second session is mitigating the effects of this phenomenon. We have two resource persons this morning. The first person that I am going to introduce is someone who serves as the Assistant Project Leader of the Philippine Climate Change Adaptation Project, Phase 1. She obtained her undergraduate degree in chemistry from the University of Santo Tomas and her master's degree in meteorology from the University of Reading, United Kingdom. She was conferred the regular Associate Research Award in the field of climatology by the International Center for Theoretical Physics at Trieste, Italy. I think I pronounced it right, Trieste, Italy. She is now the officer in charge of the Climatology and Agro-Meteorology Division of Pag-asa. So before I mention her name, may we request her to explain what agro-meteorology is all about, because it's not quite a popular name or division of Pag-asa. So please help me welcome Ms. Edna Juanillo.
Thank you very much, Marlon. Maayong buntag sa atong tanan. I'm from Masbate, so I can understand a little bit of Cebuano, but I can't really speak a lot. So thank you very much for RAFI for inviting me here, and of course to Renee and Ivy who saw me at the airport yesterday. So a very gloomy morning to all of us, although later maybe it will be not so stormy, I think. So this morning, before I proceed with the main topic, which is El Niño, sabi nga ni Marlon, agrometeorology is that branch of meteorology which deals with agriculture. So yung agricultural meteorology, ipinaiksi lang, agrometeorology. So of course, it deals with crop production, how to devise ways to produce or yield more in agriculture, depending on the effects of weather. So I'm sure you understand. So this morning, may I first, so the topic is about the 214 El Niño phenomenon. Maybe I would say the developing, because it's not yet here. We are still waiting. So I will give you the latest update and its likely impacts. Okay. So we are all familiar with our archipelago, the Philippines. It's located in the tropics. It is composed of around 7,100 low-lying islands and islets. Some of them are inhabited. 70% of our cities and municipalities are coastal areas, so it's highly susceptible to flooding and storm surges. The Philippines has a very complex climate. Why? Because it's governed by many climatic controls that affect our country. Some of these are, of course, first, we have our geography and topography. We have mountains, we are surrounded with large bodies of water. And then semi-permanent highs and lows, we call that the low pressure area and the high pressure areas, or other words, the bad and the good. And airstreams, we have the southwest monsoon or the habagat, and the northeast monsoon or the amihan. And now we are habagat, time of habagat now. Ocean currents, linear systems like the intertropical convergence zone, the easterly wave, the fronts. I think you are all familiar with this because you heard it every day in our forecasts. And of course, our tropical cyclones, which we call bagyo in our local Filipino dialect of language. Then now our topic, of course, is the ENSO phenomenon, which has two phases, the El Niño and the La Niña. So what's the ENSO phenomenon? Here in the Philippines, let me just emphasize that the rainfall is the single climatic element that can adequately describe our climate. So here in the Philippines, we have only dry or drier climate, or we have the wetter or wet climate. So we have only two seasons, the dry and the wet seasons. And more than 50% of annual rainfall is attributed to mga bagyo, no? Tropical cyclone activity. So the ENSO phenomenon. Last May 1, Pag-asa issued this S&T media release. And just the main statement is that we are monitoring presently the development of an El Niño phenomenon. So that's the summary of this media release. So that's May 1. So what's really is the ENSO, or the El Niño Southern Oscillation Phenomenon? So it's a large-scale, natural, so it's natural fluctuation of the global climate system resulting from the interactions between the ocean and the atmosphere in the central and eastern equatorial Pacific. So CEEP. So please remember CEEP because I will mention that a lot. Then what we monitor the El Niño phenomenon in this, what we call the CEEP. So the scientists who discovered the El Niño phenomenon, or the ENSO phenomenon, marked this part of the Pacific Ocean. We call this the Tropical Pacific Niño regions, just to monitor the occurrence of the ENSO phenomenon. So we will focus our attention here in this part of the Niño region, which we call the Niño 3.4, because according to our studies, this is the part when it warms or when it cools, it affects our rainfall. So this is our focus here. Phases of ENSO. So there are two phases. El Niño, or the unusual warming in the central and eastern equatorial Pacific, and the La Niña, unusual cooling. So it's the opposite. If we talk about El Niño, it's the warming, and La Niña is the cooling. So it's the same part, no, of the Pacific Ocean where we monitor El Niño and La Niña. So they cannot exist both at the same time. And it is very far from the Philippines, no? So it doesn't occur in the Philippines, so it's only the impacts that we feel. So it's not really right if we say that andito na ang El Niño, no? See, it's not correct. So it's only the impacts that we we feel, or we it's only experience, no? So I hope you are clear with that. Kasi mali, it's wrong to say that andito na ang El Niño sa Pilipinas or La Niña sa Pilipinas. So here we have the neutral. During the neutral period, or there is neither El Niño or La Niña, there is this strong easterly wind component here. So that's why we have the warm pool of the Pacific Ocean here in this vicinity of the Philippines. So that's why it's warm, and it is conducive to the forming of clouds, so there is rain over there. Well, what happens during an El Niño? This easterly surface winds weaken, so it weakens. So the westerly wind component here becomes stronger than the easterly component. Bakit sabi mo easterly? So because it's from the east, this is from the west. So we call that easterlies and westerlies. So during El Niño, this strong easterly component during the neutral period becomes weaker. So ano po ang nangyayari? Some of the warm pool, or the warm pool here in the Pacific Ocean, are distributed or transferred to that part of the Pacific Ocean. So the opposite is during La Niña, this easterly wind becomes stronger. So this becomes hotter here because some of the warmth of the Pacific Ocean goes here, are transferred here. So there are a lot of rainfall here. So during El Niño, we have reduced rainfall generally, and during La Niña, we have above normal or more than average rainfall. Okay, so this is neutral, no El Niño or La Niña. This is during El Niño, and this is La Niña. So what are the indicators so that we can monitor this phenomenon? So the ENSO indicators is what we call, the first one is the sea surface temperature anomaly. Anomaly is not what you think, no? Maybe you think about anomaly, but here we have also anomalies, just the difference between the observed and the average SST. So we call that SSTA anomaly in the Niño regions. Then we have the Southern Oscillation Index. Previously, we defined ENSO as the interaction between the ocean and the atmosphere. So when the ocean warms or when the ocean cools during ENSO, so the atmosphere just above the surface of the sea becomes hotter or becomes colder. So that's why this is the reaction of the atmosphere. So it is being measured by the Southern Oscillation Index, or what we call the difference between the mean pressure level over Tahiti and Darwin. Tahiti is somewhere in Polynesia, Hawaii, and Darwin is in Australia. Both are in the southern hemisphere. So that's why it's called the El Niño Southern Oscillation Phenomenon. So SOI, and then of course the surface wind anomaly, because the easterlies becomes weaker during El Niño and the easterlies become stronger during La Niña. That's why we have a surface wind anomaly. Any questions? Or are you confused? I hope not. Okay, so these are just some of the indicators. We have 3. Not only the sea surface temperature should warm or should cool, but the atmosphere should react in order to have a full-fledged El Niño or La Niña. Then we have this, what we call another measure of the Oceanic Niño Index, because it's in the Pacific Ocean. So is the principal measure for monitoring and assessing and predicting the ENSO phenomenon, defined as the 3-month running mean sea surface temperature departures in the Niño 3.4 region. And this is the operational definition of El Niño La Niña used by the NOAA. So we adapt this definition. So it's not just when the ocean or the Pacific Ocean or the CEEP in particular, if it warms, we call it El Niño already. So we have a criteria. We should have this 3-month or 3-month running mean. It should persist for 3 months. Okay? So these are the categories for Oceanic Niño Index. If the ONI value is 0.5 to 0.9, we have a weak ENSO or El Niño. Then 1 to 1.4, we have moderate, and then more than 1.5, that's degree centigrade, okay? This is strong. So Ms. Chua previously was referring to the 97-98. So the Niño ONI value was more than 3 degrees. So that's strong. So we have also a category for, yes, please. Can we answer the questions or later?
We may ask questions later during our open forum, sir.
Okay, pakisulat na lang po siguro.
I know we have lots of questions, but we may ask them during our open forum. Thank you.
So El Niño or La Niña episodes are defined when the threshold met for a minimum of 5 consecutive overlapping seasons. So these are the previous El Niños and La Niñas. The green ones are La Niñas, and the red ones, the red colored ones, are El Niños. So in 2002, we have here this is the 3-month average, and in order for us to declare that there is an El Niño, this threshold should be met, 0.5 and above. No, what we call the sea surface temperature anomaly in the CEEP should be more 0.5 degrees above. No, and then when it comes to La Niña, it's negative, positive for El Niño warming, and then negative for La Niña cooling. Okay. Historical El Niño episodes. So napakarami. There are several El Niños and La Niñas already recorded in our history. So in 95, so these colors are for weak, moderate, and strong El Niños. So 97-98 was considered as the El Niño of the century because nothing has surpassed the sea surface temperature anomaly for the 97, 98. Okay, so that was more than 3 degrees centigrade. I think it is here. I don't know. 2.4, almost 3. Okay. So general impacts of the ENSO on our local climate. Although El Nino and La Nina affect the climate of the whole globe, no, it's not only the Philippines, because of course we have no boundary. The weather has no boundary, so they affect all of the earth or all of the globe. Then here the impact is on the rainfall. Rainfall is the single climatic element that defines our climate. So if you can notice here, those red-colored years are El Niños, and the blue-colored years are La Niñas, and then the black-colored years are neutral, or no El Niño or La Niña. So if you look at the 97, 98, almost all of the Philippines are red, no? But there are still areas that has rainfall, like this one. Green is near normal to above normal condition rainfall, no? And then on this side, we have also the green one, which has rainfall. So it doesn't mean that if we have El Nino or La Nina, buong Pilipinas or the whole Philippines is affected. It's very difficult to really say which part of the country will be affected. Like this one, in 97 and 77, 78, most of the Visayas and Mindanao, and here also most of the Visayas and Mindanao, but here in 86, 87, Visayas, only a few areas in Visayas were affected, and also in this one, Visayas and Mindanao were not affected, only Luzon, and also with this one, Luzon, and Eastern Mindanao and Visayas. So, sabi nga ng mga scientists, as an El Nino is unique in its own way. No two El Niños or La Niñas are alike in terms of its effect or its impact on our rainfall. But if you can see here, 97, 98, it's a bit easy to predict the impacts because almost all of the Philippines are red. So this one is the monthly mean rainfall distribution during neutral. So we average all the neutral years, we average all the El Nino years, and we average all the La Nina years. And here is this the weather in the western part of the Philippines during the El Nino, and La Nina, it's wetter in the eastern part of the Philippines. But during a neutral, we also have some are wet, some are dry. That's the yellow is dry to red, but blue to green are wet. So you can now see the difficulty of really assessing the impacts or the effects of El Nino when it comes to the rainfall behavior. So here we have the 1951 to June, July, August, and the most difficult also part of monitoring the El Nino effects is that it occurs different parts of the year. Okay, so iba-iba rin po ang kanyang effect sa ating rainfall if it occurs in the middle of the year or it occurs in the last quarter of the year. So it's very difficult. Now, pre-development of El Nino, we can see that during January to May, you have dry periods also here, and then in May we have wet periods in the Visayas. But during El Nino, you can see that June, July, August, it seems that it's not affected yet, but the effect here in October only, and the rest of the year, it's not affected. This is the very recent El Nino, 2009-2010. So this is the pre-development of El Nino, mostly wet over the entire Philippines. During the El Nino, the effect, so the El Nino began in June 2009, and the effect was felt during the last quarter of the year. And then so on the next year, the first quarter of the year. So El Nino manifestations. The most critical El Nino manifestation is the Angat Dam level because it supplies 95% of the domestic water of Metro Manila. But it is a multi-purpose dam. When it is full or it is in its capacity, it is being used for power generation, for irrigation, for Metro Manila water domestic use. But if it's right now, it's in critical. Right now, it was last week we had our climate forum, regular climate forum in Pag-asa, and it was reported that it is now 164 meters. And in 2010, it went to 157. I think it was the lowest that it got. Tropical cyclone tracks during El Nino years. So it doesn't mean that although we have El Nino, wala nang bagyo, no? So I'm just showing here that during a weak El Nino, these are in 2004 we had 12 typhoon categories. We have three categories of tropical cyclones. We have tropical depression, tropical storm, and typhoon. And may I remind you that the super typhoon, we don't use it. Only the Joint Typhoon Warning Center of Hawaii, they use the super typhoon category. More than 200 kilometers per hour is already considered super typhoon by the Joint Warning Typhoon Center of Hawaii. So here, this is for the moderate. We still have the typhoon here, typhoon 8 category, and then also moderate, we have also 8, but for the strong, we have also 5. So it really doesn't mean, like now, El Nino is not here. So we expect it to come maybe later this year. So Typhoon Ondoy occurred last, 2009, no? September 26 to 24 to 26. So it was an El Nino year, no? And also this one, Typhoon Pepeng, also occurred during an El Nino year. So they are very devastating. Latest update, siguro ito na ang ating pinakahihintay. We are really waiting for. So Pag-asa doesn't have capability of monitoring the sea surface temperature in the CEEP. So we rely or we use the global climate, international climate centers because they have research vessels deployed in the Pacific Ocean. So we have these 3 international climate centers. We have the International Research Institute of US or NOAA, Tokyo Climate Center, and then of course from Australia. So they all say, it says, this is July 7, Japan, this is a bit late, this July 1 for Bureau of Meteorology. This one, every week they update, no? And this one they update only monthly, and this one also monthly. So they all are saying that the chance of El Nino increases during the remainder of the year, exceeding 70% during the Northern Hemisphere summer or June, July, August, and 80% during the fall. And also Tokyo Climate Center, neutral conditions continued through the equatorial Pacific Ocean, evolved toward El Nino conditions. It is likely that El Nino conditions will develop during the Northern Hemisphere summer, June, July, August. And for Australia, some more El Nino-like patterns emerge, but no El Nino yet. So what are the means of measuring or monitoring? So here, this is from the International Research Institute of the NOAA. The chance of El Nino is 65% during the June, July, August, September season, and expected to reach around 80% during October, November, December season. So they have models. They have models to assess or to assess the future sea surface temperature and the occurrence of this phenomenon. So the El Nino here, it's just the same table. They have described this one. So there is still the possibility, no? So this is the present Niño region SST departures or anomalies also. So in Niño 3.4, it has gone to 0.3 degrees centigrade. So ibig sabihin, it's not in the threshold of 0.5 degrees centigrade. And this is the recent SST evolution, July 7. So here, this is the Niño 3.4. If you look at it very intensively, or you can focus your eyes on this. Let us see. This is July 7. This is last week, July 1, I think. So last week, medyo more than above average then, but July 7, this is latest one, it parang medyo bumaba ulit. So it is not yet stable. It doesn't persist. The increase of the sea surface temperature is not yet stable. So it went up last 2 weeks ago, and it went down last week. So I don't know. We just have to wait and see. Okay. So we graphed here. We have this graph. This is the threshold, 0.5, and this is the 3.4, borderline El Nino. So this is the sea surface temperature anomaly in the 3.4 CEEP. So it doesn't really go higher than 0.5. So it just go 0.6. Yes, this one is 0.6, then it went down, it goes up, it goes down. So it just shows that it's not yet really persisting as we expected. So weather systems that might affect the country during the period July to December. So this is now our forecast, also based on the model or statistical model that we use. From these historical records and from the model that we use, we have, of course, the Habagat. We are now on its peak. July, August, September is the peak of the Habagat season, or the southwest monsoon season, which is also the peak of the tropical cyclone activity. So ITZZ is always there, low pressure areas, or yung masasamang panahon. That's what we are experiencing now. Tropical cyclones, occasional thunderstorm activities, northeast monsoon because northeast monsoon will come a later part of this year, around November, and then tail end of a cold front. So what are our forecast rainfall? So let us see for Cebu. So for July, we have this is Cebu, isn't it? So we have a near normal rainfall. So it's just the average. But this part of the western part of central Luzon, or the lower Luzon, is more than average rainfall. How about for August? So this part of, this is Samar, Tacloban, Samar, and the whole of Leyte, I think, it's above average, while the rest of the country is almost near average. Then we have September. Then this now have reduced rainfall here, Visayas, and eastern part of Mindanao, but the whole of Luzon is almost near normal, except for this part. Then we have October. So I think this is now the effect of the El Nino phenomenon that we are expecting. Then most of the Philippines below normal rainfall in yellow, but we have red here. This is way below normal. But Mindanao, also some northern Mindanao will have average rainfall. October and November. So almost all of the Philippines will have reduced rainfall, no? And then only the easternmost portion in Mindanao will have above average rainfall. And for December, may mga red na tayo. So way below normal rainfall in the western part of the Philippines, and below normal rainfall on the other parts. So ito rin po, we have this forecast rainfall of major river basins, and we can see that in October, November, December, there will be some reduced rainfall in some of the major river basins. For tropical cyclones, month, July. So Glenda is now the second for July. So we are still expecting one until the end of July. So we are now only July 15, middle of July. So I said that July, August, September is the season where we have a lot of tropical cyclones. So October, November, and December, if the El Nino will really come or will really occur, then maybe we will have these tropical cyclones here, but some of this will deflect or will just like Florita and Esther, they just enter the PAR and then deflect to Japan or to Taiwan or to other parts of the Asia. So summary, we have ENSO-neutral warm conditions will continue. Majority of climate models indicate that 65% chance of El Nino may develop during the July, August, September season and expected to reach around 80% during the October, November, December. And models and experts' opinion favor moderate to strict El Nino. This is from the World Meteorological Organization. So there are around 13 to 16 on the average tropical cyclones are expected to develop or enter the PAR for July to December. Thank you very much. I hope you have enlightened you. And then these are our website. This is our website, Facebook, Twitter. If you care to contact us, then you can use this. Thank you very much for your attention.